Hello, hello guys. Good morning. Good morning, guys. Yes. So, hello everyone. I welcome you to NEET World. So, in this session, we are going to see about the NEET PYQs of the physics. Okay. So, in yesterday's session, we have seen some questions. In today's session, we will continue with those questions, right, where we left out. Yeah, yes. I guess this is the question, no? Yes. At last we solved. Yeah. This was the question we solved at the last session, right? The potential difference between the point A and point B in the given figure. So, in the next, that is the next question is for the today's session, 800 turn coil of effective area 0.05 meter square is kept perpendicular to the magnetic field 5 into 10 power minus 5, it is 5 into 10 power minus 5 Tesla when the plane of a coil is rotated 90 degree around any of its coplanar axis is 0.1 seconds. The EMF induced in the coil will be. Okay. So, first of all, we need to understand what are the given terms in the equation, right. So, I need to find the induced EMF delta phi. I need to find. Okay. So, let me write that what are the given terms in the equation first of all. Like it's audible, right? Yeah, it's audible. So, the given terms are N is equals to 800 turns and then effective area A is equals to 0.05 meter square and it's perpendicular to magnetic field B is equals to, it is 5 into 10 power minus 5, okay. You can change this one, 5 into 10 power minus 5, and it is rotated by a 90 degree around any of its coplanar. So, initial angle will be 0, right, theta 1. What about the theta 2? Theta 2 will be, theta 1 is equals to 0, theta 2 is equals to 90 degree, okay. That is what they have said, like rotated by 90 degree around any of its coplanar axis. T is equals to 0.1 second. The EMF induced in the coil is, first I need to find what is delta phi, like E is equals to delta phi by T, right. So, if I find what is delta phi, I can use the formula in the value of E. So, I will use here like delta phi is nothing but NBA cos theta 2 minus NBA cos theta 1, okay, NBA cos theta 1. So, if I see here now cos theta 2, it is 90 degree, initially it was 0 and it has been rotated to 90 degree. What about the cos 0? Cos 0 is 1, cos 90 is 0, right now. So, if I substitute the values here, this total will become neglected. So, minus NBA, that is it, cos 0 is 1, okay, minus NBA. So, what is the values are given here? It is minus of 800 into 5 into 10 power minus 5 into 0.05, right. So, if I substitute the if I calculate this value, no, I can use in this formula, which is E is equals to minus delta phi by T, induced EMF they are asking. Okay. This is the calculation we need to know in this question. So, the formulas which we have learned here is NBA cos theta, right, and one more is delta phi by t. So you can calculate and give the answer in the comment boxes, whoever watching. We'll go for the next question. If you got the answer, we'll go for the next question. Okay. The next question. Yes. A rectangular, a square, a circular and an elliptical loop all in x and y plane. Okay. Rectangle, circles, like a square and elliptical. Okay. Are all are in like in a plane, xy plane, are moving out of a uniform magnetic field with a constant velocity, they are saying. So the magnetic field is directed along the negative z axis in the direction. So induced EMF during the passage of this loop out of the field region will not remain constant. So first of all, we need to understand that, like for square and the rectangle, it will remain constant. And for circle and elliptical, no. For circle and ellipse, it changes. Yeah, I'll write here. First point you need to know is, like for rectangle and square, it remains constant, whereas circle and ellipse, it is not equals to constant, it changes. Okay, it changes. So what is the given options here? The circle and elliptical loops. Okay, only ellipse or any of the four loops. Any of the four loops is not the answer. Only ellipse is also not the answer. A rectangle, circle and ellipse. Rectangle remains constant. So option A is the correct answer. Option A is the correct answer, like circle and the ellipse. We'll go for the next question. I guess the question is visible, right? We'll go for the next one. Okay. So the induced EMF will remain constant for the rectangle and circle, whereas for the ellipse and rectangle and square, for us, whereas the circle and ellipse, it is not remains constant. It is not remains constant. Okay, we'll go for the next question. The next question is a I'll zoom it out first of all. Yes. A conducting circular loop is placed in an uniform magnetic field of 0.04 with its plane perpendicular to its magnetic field. The radius of loop starts shrinking at 2 millimeter per second. The induced EMF in the loop when the radius is 2 centimeter is, okay. What is the formula for this one? Like area is shrinking, no? So area is shrinking in the sense E is equals to B dot dA by dt. It's a circular, no? Yeah, it's a circular loop. So area is 2 pi r. So radius is shrinking. So with respect to like dA by dt, with respect to time, no, dA by dt should be equals to 2 pi is the constant. So dr by dt. Okay, dr by dt. Now for this dA by dt, I can substitute the value of 2 pi into dr by dt, right? So B into is equals to B into 2 pi into dr by dt. So now what are the given terms here? So magnetic field is given, B is equals to 0.04 t and then when it's plane perpendicular to magnetic field, that is like shrinking at 2 millimeter, no 2 millimeter. So I have told about the conversions also, like km, m, centimeter, millimeter, right. So this is 10 power 3, 10 power 2, 10 power 1, 10 power minus 1, 10 power minus 2, 10 power minus 3, right. So from millimeter to meter I should convert into 10 power minus 3, no. So what will be the radius? R is equals to 2 into 10 power minus 3 per second, okay, meter per second. So meter per second, okay. So if 2 pi into 0.04 into 2 into 10 power minus 3, if I substitute the values in this equation, I will get the answer. Is it fine, right? We'll go for the next question. Yes, we'll go for the next one. So only the substitution, no. E is equals to B is 0.04 into what is 2 pi. I'll write as it is, 2 pi as it is, I'll write. So in answer also pi is there, so I can write pi as it is. So no need to substitute the value of 3.14 or 22 by 7. So into 2 into 10 power minus 3, that's it. So I'll get the answer, which is nothing but this is 4 by 100 into 2 into 2 into 10 power minus 3 into pi. So 2 2s are 4, 4 4s are 16. So it is 16 into 1 2, so 10 power minus 5 pi. So which is nothing but 1.6 mu pi, 1.6 mu pi, right. So it is 10 power, like 16 into 10 power minus 5, no, I can write 1.6 into 10 power minus 6 also. So I will get option C as the answer. We'll go for the next question. Yeah. As a result of change in magnetic flux linked to the closed loop shown in the given figure, an EMF V volt is induced in a loop. The work done, that is in joules they are asking, is taking a charge Q once along the loop is okay. So obviously it is work done is equals to Q into E, no. Where's the pen? Yeah, there's the pen. So work done will be equals to Q into E, right. So I can write this E as V, right, in volt, and this Q as capital Q. They have given Coulomb, right. So Q into V. So what is the given option here? Option 1 QV, option 2 2 QV, option C QV by 2, option D 0. So option 1 is the answer, QV, charge into volt. We'll go for the next question. Yes, we'll go. Completed, na? We'll go. Yeah. So what about the next question? So the magnetic flux through a circuit of a resistance R changes by an amount of delta phi in a time delta t. Then the total quantity of electric charge Q that passes any point in the circuit during the time delta t is represented by. Okay, they are asking about the charge, right, the total quantity of electric charge. So what will be the given answer, like for this question, what will be the answer? Yeah, so first of all, where's the question went, man? Does the question wait? Okay, magnetic flux, where is the pen? So V is equals to IR, we know, no, V is equals to IR. So in this, I is equals to R by V, I can write, right, R by V, and then E is equals to delta phi by T also we know, right, E is equals to delta phi by T, E is equals to delta phi by T. So from this two equation I can substitute and get any one of the value, right, any one of the value. Yes, obviously, yeah. So by not using this also, like I can take this and I can substitute here, no, both are same, no, E is equals to V. So IR is equals to delta phi by T, where I is equals to delta phi by R into T. This one I will keep as it is. Now they are asking about the charge, right. So like they have given the resistance, they have not talked about the current, right. So current I'll keep as it is. I'll give, like I'll write once again, wait. So V is equals to IR and E is equals to delta phi by delta T. Okay. So from this two equation, IR is equals to delta phi by delta T, where I is equals to delta phi by R into delta T. Okay. Now what about Q? Q is nothing but I into delta T, right? I into delta T. That's it, na. So I can take the value of I and substitute in this equation. So what is this? Delta phi by R into delta T into delta T. That's it. So delta T will get cancelled. So what will be the remaining term? Delta phi by R. This is the answer. So whatever given in the question I have taken, right. The magnetic flux of the resistance are given by an amount of delta phi in delta T. Okay, these are the given terms in the question. So they have not mentioned, I they have not mentioned. So I have taken the two formulas of this. V is equals to IR and E is equals to delta phi by T. So I have equated that. I got what is the value of I. So I have taken and substituted in the equation Q is equals to I delta T. We'll go for the next question. A magnetic flux, field of 2 into 10 power minus 2 act at a right angle to a coil of area 100 centimeter square with 50 turns. The average EMF induced in the coil is 0.1 volt when it is removed from the field in t seconds. The value of t they are asking, the value of t. So E is equals to NBA by T, right, formula. E is equals to NBA by T. Okay. So what are the given terms? Magnetic field is given, B is equals to 2 into 10 power minus 2 and area is given, that is 100 centimeter square, right, centimeter square, which is equals to 100 into 10 power minus 4 meter square, and V is nothing but 0.1 volt when it is removed from the field in t seconds. I need to find value of t. 0.1 we know, 0.1 V. So I need to find the t. So what are the given terms? N is given, B is given, A is given, N is 50 turns, no, right. So 0.1 in, okay, T is equals to 50 into 2 into 10 power minus 2 into 100 into 10 power minus 4, right? Am I right now? Divide by 0.1, that's it. You will get the answer for this. So this one will become 100, 50 into 200 into 100 into 10 power minus 6, no, 10 power minus 6, divide by 0.1, divide by 0.1. So into 10 by 10 I can write now. So 1, 2, 3, 4, 5. So 10 power 5, 10 power minus 6 will become 10 power minus 1, which is equals to 0.1 second. So 0.1 second is the answer. We'll go for the next question. Yeah. So in the circuit of a figure, the bulb will become suddenly bright if contact is made or broken, contact is made, contact is broken, won't become bright at all. So when, see simple, when a contact is break, no, obviously it will become, suddenly it will become bright, okay. Simple thing, that's it. Okay, we'll go for the next one. Theory based question only. In which of the following device the eddy current effect is not used? Induction furnace, magnetic braking in twine, electromagnet, electric heater. So in this, electric heater will be the answer, because in electric heater, no, like resistive heating has been used. So only the electric heater, the resistive heating has been used. Remaining things, the eddy current are used. Okay. So we'll stop up to this. We'll continue in the next session, guys. Okay. Bye bye. We'll see in the next session. Bye bye.